Alright, hello people. What's going on? After a little bit of technical fooling around here, I think I am back and I am online. Let's see if we can get this thing on the road. For some reason my OBS once again decided to not play nice. But let's hope that is all sorted out. Can you guys hear me? First of all, let's get the technicalities out of the way. Righty then. Yeah, I don't know what was going on with my OBS there for a little bit. It just kept saying going live, but it never went live, so it's been misbehaving a little bit lately during these streams. Anyway, that's neither here nor there. Welcome everyone back to a stream. I haven't really been streaming in a while. Been very busy with work. Lately. And let's see if I can actually just... I don't want to do the whole sound thing all over again every time I launch the game, so let's see if we can go to the mixer here. And just quite simply mute the game for a little bit. How about that? Right, so I haven't been streaming for a while because I've been very busy basically ever since I launched the pre-alpha 1 version, which you can see there in the chat. I posted a link. You can now actually play this game, or a very early version of this game. And you can do that by joining the Discord, where you can find the link and play the very first level, or at least the sort of very first level that I've made public, shall we say. Which is this level here that you can see in the background of the menu, as I'm sure you know if you've been hanging around for a while. And I launched that in February. And ever since that I have been working like crazy on the tech behind this. And in particular I've been working on two main areas. So one has been modability. That one is kind of still a little bit in progress, in flux, one might say. I kind of did what I set out to do though, which was to prove that we can run mods, gameplay code, as WASM, which should enable me to do some pretty cool modding, open up the game for some pretty cool modding stuff later on. And that took some time, and in the previous stream we actually looked at that a little bit. I'm actually just gonna switch out the music here for a little bit. I'm trying out some different musics, and that was a little bit hysterical maybe. Let's try out one of these classical ones that I've been using quite a few times, but I feel it's pretty nice and works pretty well. Regardless, so yeah, modding was one thing. The other thing that I've been looking at is actually switching out my graphics API. And when I say graphics API, I don't mean, you know, DirectX or Vulkan or OpenGL or, you know, any of the big ones. I mean the graphics API that the engine uses, sort of like an abstraction layer on top of the actual graphics API. And for the very longest time, I've had essentially like a self-made abstraction layer, which then allowed me to target Direct3D, web GPU, like my most popular video of all, still my web GPU video that I did almost 2 years ago now. And I'm able to target that using essentially the same game code, same engine code, by having this sort of abstraction layer thingy in between, which kind of translates the common calls into like the specific graphics API. And that is how most engines actually work. That's how all the big ones work, you know, your Unreals, and I'm sure Unity works that way as well under the hood. Now that API had come sort of into how should I say this? I felt it was kind of reaching the end of its life. It was not going to get a whole lot better than it was without like a significant refactoring. And so basically what I did was I ripped that out, or pretty large parts of that, and replaced with something else. And what that else is, I will tell you in just a little second here. I'm gonna take care of one thing. Rightio. So, what I have been looking at lately, it's called NVRHI. So this is a graphics API abstraction layer, Nvidia rendering hardware interface. It's made by Nvidia guys, and it kind of replaces my middle layer there, and allows me to target Direct3D11, which is sort of still, and has been for the longest time, my kind of main API or home API or whatever you want to call it. But in addition to that, it allows me to target Direct3D12 and Vulkan as well, if you want to go that route. And so the idea here is that if you write your own code against this guy, this NVRHI, then the Nvidia guys provide you know, backends to these three APIs, and you can make your own with relative ease, I should say. So basically what I did previously myself, I now have the Nvidia guys doing for me, and obviously they're going to be much better at actually doing graphics programming than me. And so Mohamed Yohani or Yohmani says NVRHI is amazing, great choice. I feel so myself, yes. Glad to hear it, by the way. I'm not very experienced with NVRHI yet. So I've been doing the port now for about 2 weeks, working basically only on this thing, and it's been a little bit of miserable, because I really want to work on the game itself, but I was kind of feeling like that my own own stuff was holding me back a little bit. So I felt it's probably best to just swap it out for this thing here. So I am now at a point where the runtime is ported to basically feature parity with the old system. If you see any of my own old videos, you probably seen this scene here, which is the demo level that you can play if you play in the pre-alpha 1 version, which again you can play if you get the link from Discord. And this is now running on NVRHI, and it should look basically exactly the same. That is my hope, at least, that it looks basically exactly the same. We're still running on D3D11, as you can see up here in the corner. It says D3D11. And so, what I was thinking, just as a fun little test, was what if we just try to throw D3D12 on this thing and see what happens. Hey Matt, I am back. Finally, I emerged from my NVRHI cave, and I plan to stay outside of the cave for longer this time around. Yeah, I was inside the WASM cave for a bit, and then I poked my head out and said hello to everyone, and then I went into the NVRHI cave, and I stayed there for even longer. But I'm running out of caves now, luckily, and by that I mean the tech is now basically in a place where I feel like, yes, I can continue with the game now, if that makes sense. And so yeah, like I was saying, I was thinking, now that I have it in this shape here, and one of the original sort of goals with porting to NVRHI was to be able to target D3D12. That's kind of what I want. If I can have that as my main API, then I'm gonna be very happy. Not because I like there's no sort of like perceived betterness of D3D12 that compared to 11. It's just like the tools that are available today are almost exclusively designed for D3D12 and Vulkan. And of course, if you're living in Apple world, then you're targeting metal. But tools tend to not really work with D3D11 anymore. At least they're not designed for that. RenderDoc being the exception. RenderDoc just works with most things. And so now that this is working as well as it is, I was thinking maybe we should just give D3D12 a try and see how it works. And I'm gonna be completely honest here. I'm not particularly expecting to get it working today. We might, but if we don't, then it's basically what I expected. If I say it that way. Because I haven't done D3D12 in a long time. So I've actually made my own D3D12 backend in about 2017 or 2018 for this very game engine that we're running this on. And it was pretty hard. It was pretty difficult. And it was clearly not something that like a single indie developer making their own game and also all of the art and everything, clearly not something that like someone with my skill set should really put all that much effort into. So I kind of reverted back to D3D11 most of the time. Had a little messing around with WebGPU to see if that would be sort of like the way to tap into those newer APIs. I kind of don't think that is necessarily the way, especially when you now that you have things like NVRHI to arguably fit the bill a bit better. Right. Escape any more caves and Plato will have a word with you. Yeah. Yeah, probably. I need to get him on the phone. Right, so what are we looking at then? First of all, if we look at the... Let's see, what's the NVRHI stuff? This is not prepared for at all. I promise you. It's not rehearsed in advance or anything. I've just basically got done with all the rendering features needed to render the game properly with D3D11, right? So I'm just jumping in completely cold into the deep parts of the pool here. And like I've said, I've done Direct 3D12 stuff earlier, but that was like many years ago. So even D3D12 is getting pretty old these days. Anyway, here is the NVRHI tutorial, and we can see that okay, yeah, the NVRHI won't create your device for you. You actually have to create the device yourself using just native code. So NVRHI D3D11 here. You basically create the device, you get the context, then you fill out one of these things and you pass it to NVRHI, and it creates like the NVRHI device for you. And after that, it kind of takes over, and you are supposed to be in good hands. So we basically need to do the same thing for D3D12, which I haven't done, and so that'll be interesting. Programming guide says that where is the actual tutorial? I don't remember. Yes, okay, here. Multiple swap chain textures and explicit access synchronization is necessary. This is out of the scope of this article, and working implementations can be found in the device manager classes in Donut. So Donut is like a collection of samples, Donut samples made by Nvidia, once again, and they are using the NVRHI renderer for this. Presumably things like HBA you were fixing a few days ago will need to be re-implemented for each backend. Yeah, will. I can show you in a little bit how that actually looks like. I do have Donut examples running here though. And so here we go. There are like a bunch of different samples here. This is the feature sample, which just has like a bunch of things you can mess around with. Here's the sponsor, obviously. There's a whole bunch of like... Oh, here we go. Object scene was null pointer. Whoops. So clearly not even Nvidia's own code is foolproof. Here we're running on D3D12 though, and what was the thing that I was actually wanting to show you here? It's probably not super important. Basically this is just like a test of map generation, among other things. So this collection of demos has working device managers for all of the platforms, as the tutorial says here. Working implementations can be found in device manager classes, so we have one for each. And if we take a look at this guy, we have device manager DX12. I took a little bit of a look at this stuff for the DX11 one. So we have DX11 here as well. These are kind of similar. They do a lot of the same stuff. But obviously the D3D12 one has like a little bit more, synchronization and stuff that D3D11 handles for you. So we're gonna have to bring that over as well. But I was thinking we would basically start with my own D3D11 device manager, and then kind of just like look at this guy and bring things over. Now, luckily, Donut is also MIT licensed. MIT license, just like this is actually NVRHI, but I have to go here. You see that this is MIT licensed as well. And yeah, I used a little bit of code from Donut already for things like map generation and stuff like that. And just like hardened code that is designed specifically to work with the NVRHI, so that's pretty nice. Right, if we go look at my stuff now then. I have like such an enormous number of different backends now for these things that I'm getting kind of... I'm looking forward to like erasing everything that's not NVRHI. Here we have the old D3D11 backend, Basis GFX API D3D11. So this has things like, you know, texture D3D, which implements GFX API texture. All of this stuff. So this is sort of like my own RHI. And this is what you will be running if you are if you're running pre-alpha 1. So that's pretty nice. But then we have the new stuff, and it's this thing that's called just Basis D3D11. And this is actually an NVRHI backend here. It's not necessarily super obvious just from looking at the file names, but you can see here that we're including NVRHI D3D11. And I have something called a GFX API device manager here, which is sort of like the base class, which all of these guys are expected to implement, because we will actually put this stuff in a separate DLL. Remains to be seen if that is how I actually do it in the end. I had it for a little bit of time when I was just starting out with NVRHI. I had it in the core engine, but I think it's a little stupid that you have to like link to D3D11 and 12 and maybe even Vulkan if you're using just one of those three. So I now used the Basis Engine's plugin system to just bring in one of these guys depending on which one you want. And so they all implement this device manager sort of abstract class or base class derived from this base class. And hopefully that is all that we're going to need. This is all that's needed for the D3D11 one at least. And so the idea is that we will take this one, the device manager D3D11, basically rip out things like the D3D11 device. And this one I can actually make a bit larger for you guys so you can see it better. We have D3D11 device, we have D3D device context and debug. And I think those are basically the only D3D11 objects that we have here. We have some DXGI stuff. Many of those are going to be the same for D3D12 actually. And then I have something that Matt kind of touched on, like an HBAO plus context. Yeah, here's an old one. Let's not look at that. Let's only look at this guy here. So this is again like an abstract thing that all the HBAO implementations then can implement. And here we have Basis HBAO plus D3D11, which also goes into the DLL stuff. Render AO, this is basically like the big function that renders the AO. So yes, I will need to do something similar with D3D12. I know D3D12 has support I know HBAO has support for D3D12, but I haven't looked into it yet. So gonna need to do that. But this thing here, for example, which is is also Nvidia code, as a matter of fact, but quite a bit older than NVRHI, so this works directly with D3D. This guy just takes a D3D11 device context. Yeah, here's the D3D12 interface. So this takes command Q and command list instead. And yeah, it's pretty simple to use. Hopefully it won't be that much of a hassle to implement. But we're not going to look at that today, because we can quite simply tell the game, or the engine rather, we can tell the engine that hey, we don't support that yet, by setting this flag here, HBAO plus support, to false, which will quite frankly just not it will make the game not try to actually render with HBAO plus. So that should be good. All right, what do we say we just get started here and see what we have? So that's shaders. So here we are inside of the thing. You can see here we have D3D11 metal shared is like a, well, shared between many of them. We have Vulkan 1 and we have a Web GPU 1. So these all target the GFX API, my own old abstraction layer. And there is even a D3D12 one, but it's so old that I've actually removed it here from the main repo already previously. But we're going to just quite simply create a new folder here. We're going to call it, actually I'm just going to copy this 11 one quite simply and call that D3D12. And let's poke at the CMake lists. And most of these things are actually just going to be a straight up rename. Oh, that's not how I do it. Like this. We won't have everything, but we will have most things. Let's not replace that yet. That can be replaced, but I don't want it with capital letters. Yeah, that's fine. So let's comment out that HBAO plus stuff. You can see here what we have. I'm just gonna move that off to the side. So we have some stuff here that we actually need to kind of hook into. We need to make the engine aware of this. That, oh, this is actually a rendering backend. We can use this to render to the screen. And that happens through these guys here. And then we quite simply just have the one device manager where we're going to spend probably like 90% of the time today. So that creates the device, it creates the swap chain, and it basically like pumps the system. Then we have some of this shared stuff that we looked at previously. We have an editor render window and a render window. So the editor, if you haven't seen, that looks like this, and it quite simply, like, we have this window here sort of embedded into, just open some quick level here. We have this window embedded into like a WinForms application, so this window is going to be a bit different from like your typical Win32 window. Right, and then you just create things in the scene. So that is what this guy is providing us. I think we should be able to just use these exact same classes with D3D12, which is Win32 after all. And then we need to look at these things a little bit here. So I don't exactly remember what libraries you need to link to for D3D12. Oh, this is a static library, so it doesn't have. Let's see here, feature demo. This guy probably links to some stuff we will want to have. Yeah, so it links to D3D12, NVRHI D3D12 library. We have that already. And then quite simply links to DXGI, DXGUID, and then D3D12 and 11. So we have almost everything. We just basically need to switch that to 12 as well. I wasn't sure that was the name, but it seems to be. So we have the NVRHI D3D12 here, and also the base library. NVRHI has like a core that provides, you know, most of the things that makes NVRHI actually NVRHI, and then it has the backend code, and they're split up into different static libraries. So the core engine, the basis core engine, links to only this NVRHI currently, and I'm hoping to keep it that way. So core engine doesn't actually really know what graphics API it's talking to, and neither should it. But it can query that, obviously, if it needs that information, and then do different things with it. Okay, so this thing can still be here, and it will be enabled. We're just not going to use it. D3D12 exports. Not sure I need that, but it's like a legacy that has been following me around for a while, so let's keep it there. We don't want those though, and I don't think, now that I'm looking at this, I don't think I had it correctly set up for the other one either. Yeah, it's supposed to be D3D shared. Look at that. So we actually had an incorrect path in the D3D11 one as well. That's supposed to be that. And then we go here and we correct it for this one as well. And at this point, I'm just gonna regenerate this thing and make sure it builds again. And while it is doing that, we can take a look at those new files. So that is saved. Configure, generate, and open. So, oh, did I? Oh, I shut down the donut one. Yeah, we can reload that. That's probably fine. Shut down the donut one. But this should now be pointing to the correct place. Yeah, D3D shared. Yeah, so I'm trying to like separate out all the old crap that I had for all of those old backends, and go with just like a much smaller, leaner set of things going forward. You can just see like the difference here in files between, you know, all those compared to just these, and most of these files are actually really short. It's like 40 lines. 33 lines, that's like 12 lines, and plugin one is also pretty short, and it does almost nothing. So it's essentially just like this file, this device manager file is the thing that contains everything, and this is, well, 500 lines, so it's not super long, but it's not super short either. Render window, okay. We have some include paths that we need to set up as well, probably. Or are those actually just like IntelliSense errors? They probably actually are just IntelliSense errors. IntelliSense hasn't picked up on the fact that we changed those. Can be a little slow sometimes, but okay, that's fine. And here you can see, for example, here is how we get actual errors and warnings and all of that reported to us from NVRHI. So NVRHI has its own validation layer, which is really handy because it works with it doesn't depend on the graphics API that you're using, right? So even though I have been using just D3D11 so far, we have this enable validation stuff here, which adds like one additional level of checks on top of everything else, and tries to sort of prepare my code already for working with, you know, the lower level APIs. So that's kind of nice. Okay, how is it looking? I think it's looking pretty good. So let's let that build for a bit, and we'll go have a look here in the D3D12 folder. So I'll actually just delete that completely. We can bring it back when we are at a place where it actually kind of makes sense to start looking at the HBAO stuff. Right, backend export plugin, and then the device manager, like so. So if I have a goal for today, it would be to actually like get into the main menu of the game with D3D12. That would be super awesome. I'm not sure we're gonna get there, but it would be nice. I'm counting on NVRHI just working with my DXPC shaders that I have for D3D11, but eventually I'm gonna want to actually turn those into DXIL. But we'll see. We'll see. Let's open up the main CMake list file here if my computer is willing and wants to help me out. It's a little choppy currently because I'm rebuilding everything. Yeah, and I get a bunch of warnings from like, and that's actually from some old D3D11 code. Here's from like Bullet. Nano VG, all kinds of things. Yeah, the core library built though. So let's just see if the okay we have some issues here. They should not be very tricky to fix. It's just that I have never actually compiled those things because I have my paths wrong there in the CMake stuff. I am going to have to let this finish though because it's so choppy. Streaming and building at the same time. Okay, there we are. So let's have a quick look here and fix these issues. Here we go. Like I'm honest. I think my focus right audio interface is just like about to just, you know, break down or something. It's it gets these weird things where like the audio just stops, and I don't necessarily realize that it stops because I have like direct monitoring out or direct monitoring on, so I hear myself talking to the microphone, but like I just can't hear like any music from the computer or anything anymore. And then I go like, okay, I probably just need to like unplug it and replug it, and then it works again. So that's a bit funky. Okay, what is the thing now with this? Are you just... Okay, so yeah, I think I moved these guys. Did I move them out of the... No, they're still in the GFX API namespace, so that's fine. Let's see if we can actually build this. We cannot build this, okay. Okay, and the reason we can't build it is because we are still not including it. Where did I include it previously though? Like that thing should just be taken away. Like so. Yeah, we're including it here and there. Okay. Oh, is it actually? Include? Yeah, okay. So it should find those. Include and source. Yeah. That's strange. Yeah, we have the same file twice here now, because I have it like I have it here where I actually want to keep having it in the future, and then I have the old place which is gonna go away probably like, I don't know, next week or something. This is the guy that I want to actually include, or actually that one is the guy that I want to include. Yeah, that's fine. So show me your include paths, please. So it's D3D basis D3D11, then go back one level, basis D3D shared and include. Yeah, that would be here. And here's the file, render window 32. Oh, but hey. Maybe the problem actually isn't... Maybe the problem actually isn't in the include. The problem might just be this API, right? Yeah, so here is where I've actually taken it out. Okay, I thought I had done that, but again, since I had those include files incorrectly set up for myself, I was actually sort of unknowingly editing the wrong files there. I was editing the old files. And these are now the new files. Yeah, so we need to basically like take that away. Replace it with just that. I'm just doing it by like one by one here so that I don't mess anything up. And that should be good. So that now builds. Yeah, and then do the same thing here. Okay, okay. Well, previously I I said that this isn't rehearsed, so you know, if you didn't believe me then, you probably believe me now. This is just absolutely winging it. And now we should be able to build this guy. And we do. Okay. Okay, so fun. Fun for the whole family. Now then, when we actually go and add this D3D12 library here, we are going to want to make sure that we do the same tweak there. We don't have to modify those window classes, but we have to modify that one include. Yeah, this looks good. This looks good. I mean, maybe we can even do. Let's just quickly do this to like spare ourselves from embarrassment later if I do something stupid. Yeah, that looks good. All right. So what we can do now then is go to the main CMake lists file and include that project first of all. That's not the main one. That's the core engine. Core engine one. That's the main one. Isn't it? Yes, it is. Just here on the other side. So here we have D3D11. Let's just add D3D12, and here we still have the old one. Some like web GPU stuff, whatever. Leave those for now. And I'm also going to take Trampoline, which is like the EXE project for the game. The game is a Zig game. It's written in Zig, but the EXE is still written in C++. It's sort of like a launcher, you know, kind of like the Unity launcher. It's written in C++ for a Unity game and kind of loads the C# code and all of that. And we have sort of like the same thing here in Basis, where Trampoline is the launcher for a Zig-based game, or really like a game that's not completely written in C++. What do we have? Basis Device Manager D3D12 cannot be found. And that would be probably because I forgot to rename it. Yes, that is exactly what it is. And there we go. Okay, so now we have this other backend here, D3D12. Let's collapse some of these. We don't need the shared ones, or we need the shared ones, but we don't need to look at the shared ones. So in here as well, I'm just gonna quickly rename these guys to D3D12. Right, so the plugin is what we are actually loading. This guy, D3D12 plugin. Oh, no. Nope. Yeah, not that. Let's close that. Export. Here we go. This guy. The plugin here is what we are actually loading. And the plugin can do, you know, essentially anything. I do the physics engine integration also via these plugins. So, you know, there's a Physics 5 plugin, for example, which looks like this. So it's basically exactly the same, just named differently. And so you don't need to necessarily do graphics rendering in these guys. They can do anything that you don't want to put into the main core library. And importantly, what this thing is or what this thing does, is that it has something called a backend, which we haven't renamed yet, so it's complaining about that. But I wonder why is it complaining about that? D3D12 plugin, that's what I call it, right? Yes. It's probably just confused again. But we'll see. I'm gonna comment that thing out. And probably also that thing. Let's see if we can... and that thing. See if we can build this now. Okay, it's because of that. There we go. Okay. We're getting into sort of like a renaming cascade here quite quickly with these things. 11. I should really just have done like this. I was trying to be smart about it and do like a little at a time, and that way I could explain things as I'm going, but clearly that's not working out, so let's just rename these guys. D3D12 backend, yeah, probably still called 11 here, exactly. And now this should all be good. And I was complaining about the device manager, which we don't have still. But that's fine. Here we have the HBAO plus context. So basically we'll want to do that. Yeah, I think we'll leave this here. When we just make the device manager return like a null pointer for now. And that'll be fine. So error initializing D3D12. And we quite simply don't have this here. I don't think we actually need that there though. You can sort of see that I've been messing around and moving things around a little bit here on the D3D11 side. Yeah, we don't need to include there at all. So we can take it out. Hey Cactus, welcome back. It's been a while. Okay, now we can go back to the plugin and actually uncomment these places here. So what is happening when we load a plugin in the Basis engine is that this create plugin function is called from the engine, passes in the client and the server if you need those for anything, and you are expected to return a plugin, so something that derives from plugin, from Basis plugin, this guy here. And then at some point later, when it's destroyed, you're supposed to get rid of it, right? That's kind of simple. What's that void doing there? That's not really my coding style. Anyway, we have a DLL main. If we need that, we don't necessarily really do, but we do get like the instance here, which you can then pass to Win32 when you're creating a window and all of that fun stuff. Okay, then the actual plugin itself, it has a bunch of hooks that you can hook into after all plugins loaded, before all plugins unloaded, before client created, after client created, and then before client destroyed and after client destroyed. They're all client related things because the client is sort of managing the lifetime of the application. So you can do things at various points. But that's basically it. Like you don't really get like any update registration hooks or anything like that. You need to do that yourself if you want the plugin to be updated. You can still do that though. But so far most plugins are actually just like implementing something that the engine would then call on its own. And here we are registering a backend with the renderer. So register backend, this guy just quite simply like takes that pointer and stores it somewhere. Make sure you haven't done that twice. And so before the client is created, we register a backend so that when the renderer is then initialized, it has the backend ready to go, right? And after it's destroyed, we unregister it and then we delete the backend. The backend itself, if we look at it here, is pretty simple. It used to be much more complicated when we had our own GFX API stuff. But with NVRHI, essentially what you want this backend thing to do is to create your device manager and then destroy the device manager. And as like a separate special thing, we have this HBAO context business going on here as well, because it's dependent on the actual graphics API that you're using. But this is the most important part of the whole backend. When it starts up, it asks the backend, hey, give me a device manager. And when it is shutting down, it gives the device manager back for destruction. And so that is basically what we will want to be doing here. And with this whole sort of loop set up, we can quite simply switch the renderer by giving the game another command line parameter, and it will load a completely different graphics API and all of that good stuff. Too much C++, my eyes hurt. Yeah, might be a little bit of a rough stream if you don't want to look at C++. Shouldn't be like just a whole lot of code though. I don't think we will look at that much code. Basically, we have this one class that we want to figure out. That makes sense. HBO plus context. It's because of this, obviously. This, yeah, that doesn't work now, but this would have included the thing here. Yeah, okay. I'm just gonna forward declare that. So it's in GFX API. I'm just gonna forward declare it here, so that we don't have to really think about it, and we can just return a null pointer there and call it a day. Oh, that's parameters. Context, there we go. Context. So let's rename this guy, and we're not linking to D3D11, so we will probably get unhappy compilers if we leave those things in. And yeah, those can just be commented out. So I will probably have them in that exact form later, so that one as well. That's fine. And then we will want to have D3D12 there instead, right? So D3D12 inside of NVRHI. And create device. This is the function that we will want to be calling. It expects a device description, just the message callback, which should, if I remember correctly, be the exact same thing that we already do on the D3D11 side, so that should be taken care of. We need to create the device, and we need to give it some cues. And from a very quick look, you need to give it the graphics cue. You can give the compute and copy cues as well. And I think we'll probably do that because we'll most likely just be copy-pasting that stuff over from the donut initialization stuff. And then we have some configuration stuff here. So these are not like D3D12 native flags necessarily. These are like NVRHI configuration things. And we will probably just keep these at their default values anyway. If enabled, the device's capability, create root signatures with this flag. Yeah, I don't pretend to know what that means. We can look it up, obviously. but I'm not going to do that now. Aftermath, no, we don't use Aftermath currently. There's like an Nvidia system to like debug GPU crashes and things like that. Enable logging the buffer lifetime. Oh, that's interesting. Good to know that it's there. But yeah, we need to fill in one of these guys. I don't think we really need to necessarily do anything with the rest of this stuff. But we'll see. We will quite simply see what happens. And I'm just going to bring this thing over to my other screen for a little bit. I can kind of cheat. Let's just rename all of these things to that. All of them. There we go. And we don't have the device yet. We will never have an immediate context. Not necessarily that either. And not this boolean yet. So, let's copy, not copy, but comment that stuff out and just do return null pointer. And we can just copy that out. So, I will uncomment this stuff when I have an HBAO plus context for D3D12. Sometimes later down the line, I'm sure. Okay. Right, so we have some back buffer business using the, we're essentially getting the Direct3D11 texture out of that. That's why it's complaining. Maybe we can just put in the device thing there. That thing is not coming back, but I'm leaving it here because like just there's probably going to be some other thing that is sort of like slightly similar to the immediate context, like the queues or something. I'm gonna have to release them, so I'm kind of leaving that there to remind myself that okay, we did that for D3D11. Let's figure out what we need to do for D3D12. And there, of course, we don't have the device. I'm hoping the swap chain creation will be mostly the same, but might not be exactly the same. I have some donut log stuff that we can probably take away from donut from D3D11 as well. Alright, so we have a few things that we need to do for D3D12. We need to create the device and the queues. We need to create the swap chain and get the buffers out of that, so that we can get the correct buffer to render to. And then we need to set up the frame fences, because we need to do synchronization now with D3D12 that we didn't need to do with D3D11. So the device manager base class, which we have here, this guy has a few functions here to manage the back buffers. We have current back buffer. You can get the current back buffer, and here you can see we're already working with NVRHI stuff here. No D3D11 or 12 or Vulkan anymore. Once we've gotten to this point, we are quite simply working with NVRHI. Anyway, you can get the current back buffer, you can get the back buffer with an index. So typically you would have probably 3 of them. So index 0, 1, and 2. You can get the current back buffer index. You can get the count, right? And then the frame buffer is the render target essentially in NVRH terms. I guess frame buffer is kind of like it's used by Vulkan and OpenGL or something. Don't exactly remember. But anyway, these are the render targets that we'll be rendering to, and each of these back buffer textures will have their own render target. So again, you can get one with an index, or you can get the current one. We need the device manager to handle all of this for us, because the game expects it to kind of just work in the background, or the core engine expects it to just work in the background. The device manager D3D11 is a bit wonky, because we have actually let's see, how did this work? This is like a little strange in some ways, because we are creating the swap chain with like, I think 3 of those. Except I can find it now. Oh, there we go. Buffer count. Here we go. Buffer count 3. So we're creating the swap chain description with buffer count 3, and so it has 3 buffers internally for triple buffering, but we're still only essentially using the first one, or it kind of looks like we're using the first one. With D3D11, it kind of manages it internally, so we're saying here that okay, we have just 1, and the current back buffer index is always 0. This is not going to be the case with D3D12. We have to loop 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. And so here we have just 1 back buffer, which is here, and we've gotten this thing out of the. Oh, there it was actually. Yeah. So this is the thing that we were looking at. Create back buffer, so it gets the swap chain, it gets the buffer with the index 0 out of it, and stores it here in this D3D11 texture. Then we're creating an NVRHI buffer handle for it with this, so we're sort of like wrapping a native texture inside an NVRHI texture, and then we're I'm just using detach here to like get to manage the reference count directly, but this is now the back buffer, and so we will do this 3 times with D3D12 as far as I know. And then we create a depth stencil buffer here in D3D11 using just like the normal, you know, this is the NVRHI device, and we just create a texture. So here we're wrapping a texture that we've already gotten from the D3D device, and here we're using just the normal NVRHI device. If that makes sense. And that is probably going to be the same. Yeah. So the back buffer needs to be recreated if the window size changes and stuff like that. That's why we have this release back buffer, create back buffer as like separate functions. Because if we go have a look here, I'm going to make this a little smaller so I can see a bit better. Here we go, so resize swap chain. We're releasing it, resizing the actual swap chain, and then calling this, which calls the create frame buffer thing. Yeah, okay. Yeah. Okay, in a minute I'm gonna have a good look there at the donut code to basically let's see what is that. Probably something that we can take away here from the D3D11 side. Yeah, I'm gonna have a look at the donut code to see how they actually create all of this. But before we do that, let's do one thing. Let's comment out this stuff here enough so that we can actually build this. And just kind of willy-nilly commenting things out here. This is not going to work, obviously. Let's just make sure that we can actually build this thing. We cannot build it yet. Okay. That's because I took that out. Okay. So I want to make sure that we can actually load this plugin that we've created for ourselves here. Yeah. There we go. Okay. So now we run the game. We're still going to be loading the D3D11 renderer. See it up there. And we can also do like app.list plugins. And we can see here that we have, I can unfortunately make this larger, but it says basis NVRHI backend D3D11 version 1.0, and that would be like the string that we print here from the plugins. So I already added a command line parameter here way before I even had the D3D11 renderer working. If we give it this GFX API D3D12, it loads a plugin with the name basis D3D12 instead of D3D11. So I've never run this. Let's run it now. I'm going to add that command line here. Like so. Now if we run it, it won't work because it will, you know, it will just crash. But we should still get into this thing. So let's put a breakpoint there. This is now released, so let's see how well it actually debugs. Yeah, there we go. Okay, so now we're loading our new D3D12 backend, and now it just fails. Right. So what is happening here is that we're now inside the renderer. So this is not in that DLL, but this is in the core engine. And it's asking here the device manager, which is now one of these device manager D3D12s, to create the device, get the device, and then add a reference. And the device is going to be null here, so that's why we crash. So we didn't get very far, but you know, we're loading the correct plugin now. So let's get rid of that, and we can have a look at the donut stuff to see what we need to do there on the D3D12 side. I think they're using like slightly newer versions of the DXGI factories and all of that than we have on the D3D11 side. So let's just, you know, use whatever they are using. So here we have like they're DX11, but it's the same thing. So they have DXGI Factory 1 here. They actually have DXGI Factory 2 here on the D3D12 side. And I know some of these things are like a little bit fiddly. You're sort of supposed to use certain versions for certain things. Typically you can just use newer versions without much issue, but then maybe you're kind of raising your operating system requirements while doing that, blah blah blah. So let's just use the same ones that they are using. Right, and this is basically now what we need to have a look at. Here we can already see some vectors here with those swap chain buffers that we looked at. There's probably going to be, let's see, we have RHI swap chain buffers, and there's going to be some frame buffers, but they're probably in the device manager base class here. But I am going to go make myself a cup of tea, and it should not really take all that long. Probably like 10 minutes tops. And when we come back, we're going to continue with this. Let's put on one of my quick break visuals here for you guys, and I will be back within 10 minutes or so. Alrighty then. Tea break's over. Hey Wookie, welcome back. It has indeed been way too long. But hopefully that is now behind us and I will be able to stream more regularly again. One thing that I was thinking while I was making my cup of tea there was let's rebuild this in debug. It takes a little while, so we're gonna let it do its thing here while we take a look at the device manager here and figure out what we actually need. So right, we need the DXGI factory, just like we have there on the other side. Just like the version number is different. We need the device, obviously, and we need the 3 queues. So we don't have the immediate context, but we have the queues instead. Then we have the swap chain. They're using a swap chain 3. What do we have here? We have just a swap chain. They're storing the adapter here, which they don't do here. Oh, they are actually, okay. And they have swap chain disk 1. And here's just a swap chain disk. I'm not sure I'm using the exact same versions of these things as they are here, but I think I might be. So we'll have to figure that out. Full screen disk separately for some reason, alright. Tuning supported false. Right, okay, so we're using some other, like, flip model or whatever it's called, probably here, with D3D12, which supports steering even in window mode. I think that's what that's about. But we'll see. And then we have the swap chain buffers. They have these in a stud vector for some reason. Maybe that is what I have as well. I don't remember. And then right, these are the, yeah, even though it says NVRHI here, these are actually the D3D12 ones. Yeah, I don't use these ref count pointers. I just use raw pointers. I like to be more explicit about my ref counting. Texture handles, this is the actual NVRHI swap chain buffers. So probably 3 of both. Then we have a fence, and then we again have most likely 3 of these fence events. So that would be the explicit synchronization stuff that we need to do in D3D12, which we don't need to do in D3D11. And they have a frame count. Wonder what is that used for? Let's have a look. Yeah, it's used for the fences. Yes. Okay. Okay. Yeah, that kind of stuff can be a little complex. I mean, it's always made out to be very complex. I don't think it necessarily needs to be, but it can be a little, and it can take a little thinking about it and figuring out how it works. You don't want to get that wrong. No, otherwise you're going to be waiting on the frame to, to complete before doing the next frame and all of that. And your frame rate suffers. Okay, what do they have then? Adapter name, render string. I think this is basically just implementing the interface that they want there in Donut. We don't really need to care about this. We kind of have most of that stuff handled for us by the actual device manager here in Basis. So this thing handles things like the resizing the window. It actually, yeah, okay, we have a vector here as well. It's just not a stud vector. Okay, yeah, it doesn't, yeah, D312 doesn't build, but that's fine. I'm gonna fix it up in a second. So the base class device manager handles the frame buffers. It has a vector of these guys, but these frame buffers are pointing to raw sort of textures. So we just need to wrap those textures in NVRHI objects, just like we did for the D3D11 side. Right, and then we have the depth stencil buffer, which is just an NVRHI stuff. So these virtual ones are the ones that we're going to want to actually implement here. Rightio, and I think these these window creation things are actually just fine as they are. They're just virtual here because like these actual classes don't really exist in the core engine. That's fine. Okay, so let's start switching out some of these types and adding back those device objects and stuff like that. So I think what I'm gonna do is probably, let's make this the normal size. I'm gonna move them over here to this other screen. Just so that I can see both. And we'll take a look here at what we have. So yeah, we have a lot of stuff here. Let's just close all but this and start with the factory. What is the the include, first of all, is slightly different. This 1.5. Yeah, that looks good. And then the device, or the DXGI factory they're using is factory 2. So sure, we can do that. The adapter is actually just adapter, but we have one here. That's probably fine. We want our device back. It's going to be a D3D12 device this time around. We don't want the device context, but instead we'll want these queues. Just copy these guys over, and like I said, I'm not really using these kinds of smart pointers for the reference counting. I want my reference counting to be very explicit, because that's kind of how I'm used to working, and that was how I set up my own abstraction API to work. So that's why I'm doing it this way. D3D11. Let's see here. Swap chain. There's actually swap underscore chain. Come on, chain. Desk. No. Swap chain desk. There it is. Okay. So we have a swap chain disk. They're using a swap chain disk 1. Not sure if that's important or not, but let's have it. And let's have the full screen disk here as well. All right. We do not want this debug object there, but do we want something else instead? Not necessarily. We want the swap chain number 3 is undefined. Really? Oh, why is it undefined though? Because I have the correct, or I have the same, shall we say? Oh no. Oh no. Okay. I'm being bad. I'm being bad at my job again here. I'm modifying these guys. Let's not do that. Let's put it here instead. That's where we want those. And now we can probably, yeah, now we have swap chain 3. So it requires this DXGI 1.5 header. Okay. Okay. What then? Factory device, or factory adapter device, and the queues, swap chain desks, adapter was there. Yep, that looks good. Okay. And then we have those vectors. It's kind of stupid to create a vector, I think, here, because we will have just like 3 of them. Let's have a look at how many they actually create. Yeah, so they create the same number, or they resize them to the same size as buffer count. The buffer count is almost certainly going to be 3. We can verify that still, but anyway. So it somehow seems a little silly to place those on the heap when we could just as well have them on the stack, not have to allocate, and also they'll be, well, they're pointers, so we're gonna have to jump anyway, but at least we're not gonna have to jump to actually get those pointer values, right? So why don't we actually make that a static vector instead? Let's quickly see here if we can find that the actual count that we have. Okay, device params. We can of course run this thing. There's nothing preventing us from just running this code and seeing what comes in there. But I'm pretty sure it's going to be 3. But let's not assume. Let's see what happens. Yeah, so it's 3. It is indeed 3. So let's do all that good stuff that I just said. And rather than having stud vectors here, we're gonna include core static vector. And the static vector just allocates everything on the, well, in place. It's not necessarily, doesn't necessarily go on the stack, but it allocates it in place there, right in there. They're the object. And so we'll make something like, make the maximum value like, I don't know. It's probably always going to be 3, but maybe we'll make it 4 or something. I don't know. I really don't know. Vector of, this would be D3D12 resource, I think. Let's just make it 3. And this is going to be called swap chain buffers. Static vector, thank you. Maybe we can be a little nicer about this and go like static const max buffer. I'm writing too much sig where I don't need to specify the type there. Static const u32 max buffer count, and let's just call it 3, and then we can just, because we're gonna create a bunch of these guys. It's a static vector again, and we will want the NVRHI texture pointers, and these are the RHI swap chain buffers. NVRHI swap chain buffers, right? And then we'll want the fence, so that would be a ID3D12 fence. Fence. Come on, D3D12 fence. There it is, fence. And we'll call it the frame fence. And then we want one more of these static vectors. And we have the, what's it, handles. Handle in large. Handle, yeah, that one. I want that as well to be a static vector. There we go. And we call these the frame fence events. Right. And then we want the I'm gonna count the frames. Just want to do uint64. They're calling it the frame count. I think I'm gonna call it the frame index instead. I think that is sort of like the frame number, maybe. Maybe frame number is better. I don't know. Frame count is kind of weird. Like so. And what then? They actually hold on to the NVRHI device here, but I'm not sure if we really need to do that though. Maybe we do. Oh, actually, it's probably already provided for us here with, yeah, M devices here in the base class. Okay, so here we have a vector. We could make this the swap chain frame buffers, right? Okay. Yeah. So here we have swap chain frame buffers. Here we have swap chain buffers, just like the D3D variant. And then we have the NVRHI, not frame buffer, but texture. Yeah. It can get a little confusing. And here we have just the back buffer, yeah. Because again, D3D11 just works with one. Okay. Okay, yeah. I think I think this is correct. We can get rid of that debug object there. And now we kind of have all of the objects here that we need to render, I think. I mean, it says NRI, NVRHI, and Falcor. What the fuck is Nvidia doing? They're doing lots of different things. So NRI is also let's see if I can find it here. Nvidia NRI. There we go. So this is also a render interface, and this is a lower level sort of deal. They I think I found actually like an issue here, which, yeah, here we go. What's the relation with NVRHI? So someone lists these things here. I don't know who this guy is. Maybe they are actually working for Nvidia or not, but it says NV there at the end. Anyway, you can read through this yourself if you want to, but this serves a slightly different purpose. NVRHI tries to make it easier to work with the more recent graphics APIs. NRI doesn't necessarily really do that. The main point of NRI, if I understand it correctly, is just to give you sort of a unified interface to all of them. But it doesn't take care of, you know, synchronization and memory management and barrier management and all of that at like quite the same level as NVRHIs. And so they are both kind of used for the same things, but at slightly different levels. And NRI also has some features that NVRHI doesn't, and vice versa. So yeah, non-goals, high-level D3D11 like abstraction. I think NVRHI is much closer to D3D11 than NRI is. Fun fact: I was playing Indiana Jones, the new game, and I saw that they're using NRI there, at least for something. So that was kind of fun. apparently idtech, or at least that version of idtech is somehow using this thing for I don't know, for something. But yeah, that is not why I want to do this. I want to specifically be working at a higher level than D3D12 or Vulkan. So that is why I'm using NVRHI. But NRI would, as a matter of fact, deal with this swap chain business for us. As far as I know, it actually has that feature. That's something that NVRHI doesn't do for you. You have to kind of do it yourself. But it's a pretty small price to pay, I think, for getting to work with a really nice API. Okay. Anyway, let me just have a very quick look here. So this is the donut stuff. We have the factory, we have the device, we have the queues, swap chain. Yeah, I don't think we want that. That is that came from the D3D11 side. We don't want that. We want these things instead, right? Swap chain buffers. Maybe we'll actually, should we call these just back buffers? Back. I'm gonna copy that thing, so that if I get confused later, I can go like, okay, what did Donut actually call those? Back buffers, right? Because I call it a back buffer here on the D3D11 side. It's an NVRHI texture, and if we look at where this thing comes from, it comes from getting buffer 0 out of the swap chain, storing it in this thing, or getting a reference to this thing, and then wrapping that into an NVRHI texture handle, which we then call back buffer, right? I bet if we look at this here in Donut, I bet they're actually doing the same thing. Yes, they are. As a matter of fact. Create render targets. They are iterating over all the 3 buffers, and they're getting the buffer n, not just the buffer 0 as we do here. And they are creating that sort of wrapper around the D3D texture and then storing it there. So I tend to call it the back buffer once we've sort of gotten it off the swap chain. They just call it swap chain buffer all the way, but then they're actually calling it back buffer here. So you know, make up your mind. Anyway, I think this is nicer, so let's go with that. All right, and now we can go here and we can, first of all, make sure that these things that we commented out kind of haphazardly previously, just to be able to build, are uncommented. Yeah, we don't want that. We wanted the rest. So again, we want the factory, we want the adapter, D3D device can come back, and then we have graphics queue, compute queue, and copy queue. And we're going to want to feed all of those to NVRHI. Then we have the swap chain. We don't have the debug thing. No, thank you. We don't have the back buffer either. So that's all good. Yeah, I don't know. Then we're going to initialize those later on. That thing will stay there for the time when I actually bring that back. But we'll want to initialize this probably to 0. I'm not really sure if it actually makes any difference. Let's initialize that to 0 as well. Okay. We have the default message callback that can stay. Let's just rename these to D3D12. And let's not go that far. Okay, that's good. Right, so what is happening now then when we create one of these guys? We call init on it, and we pass it the client, which, do we actually use this for anything? Yeah, we do actually, we pass it to those. Okay, an instance as well, probably, also goes to the window, yes. We create the DXGR factory. Okay, so let's start with this. Let's see how they do it here. What is going on? Create instance internal. What? They're using sort of almost like Vulkan terminology here. Create instance internal. I bet this was actually just copy pasted from like the Vulkan side, because in Vulkan it's actually called the instance. Anyway, basically want this thing here. Enable debug runtime. I don't think we're really using that currently, but I'm gonna do this. That is, by the way, not called that. It's called, what is it called? It's called that. DXGR factory. Let's do like this. Tool enable. Actually, let me just copy that. False. So I'm gonna bring it here. Just later, if I go like, what is this? I can figure out immediately by just looking at it. I'm just gonna leave it as false for now. Okay, so that would be the first step. What is the next step? The next step is enumerating over the adapters. Right, and we're just getting the first one. And that's probably fine. I think I'm gonna leave it like this for now. I can always go back and like fine tune all of this, so that you can, if you have more than one, you can you know, select the correct one. Blah blah blah. I'm not gonna do that right now. That is not really D3D12 stuff anyway. But what they are doing is they are enumerating over the adapters and then figuring out information about them. That's all fine and good. We're not gonna do that right now. So we basically have init done now. Get the first adapter and then return true to the game. Then at some point, this is probably going to create the device. We can actually have a look at what's the next step here. So we go to renderer.cpp and we go to device manager. Find that. So we create the device manager. We get some stuff off it. I'll get back to that later. And then we create the window. That's fine. We go to init internal, and here is probably where we create the device. Where do we call the init? Oh, the plugin is probably calling the init. Plugin. Not the plugin, then probably the backend. Yeah, okay. Create device manager. So we're just initializing it here. Yeah, the backend has the client and the instance already, so it just passes them on. Create device manager, exactly. Okay, so that stuff is run here. And here's actually some commented out code when I just had like the D3D11 stuff directly plonked into the main engine library. We're not doing that anymore. So here we're calling the init inside of that thing. Then we're getting like what kind of shader language are we using, all of that. Creating the windows, that should also already work. And then we're going to init internal. And here the first thing that we do is we create the device. Cool. And a few things here. If this debug device is true, that is where I have set up the D3D11 debug layers. I'm probably gonna have to do that the same for D3D12. I mean, the crashes and issues are more confusing on D3D12 anyway, so it makes perfect sense to set that up, but we'll see if we do it right now or not. Back buffer sRGB is false currently. Yeah, I do my sRGB handling separately in a shader, so the back buffer is just like, it's not sRGB, it's just gamma. Enable validation. This enables the NVRHI validation layer. That's super handy to have, so we'll want to do that. The D3D11 backend already does all of these things, so we can look at that. Right, so we create the device, we get the device, and then we create the swap chain. This is sort of like the order of things. I'm hoping that the order of things can stay the same with D3D12, but you never know. Might have to change some things. Yeah, these are just like hard errors if these things don't succeed. So create device, create swap chain. And then we are actually sort of on our way. Here we're just like creating all kinds of things all of a sudden. So cool. Let's see if we can make that happen. So create device is here. How does creating a device look like again in D3D12? Right, so here we have the enable debug layer. Maybe we can just do that right away then. That's interesting. They just have a function that gets the interface, and then you call it enable, and then you essentially let the reference die, like you release it. Sure. Something called GPU validation as well. Yeah, maybe we'll want that as well. Not sure. Then we have the adapter index, which in our case is always 0. And we do some last minute checks on that, apparently. Render a string and is Nvidia. Yeah, not sure if we need to do any of that. We do need to pass the adapter. Yeah, so they're getting the adapter here, right? Okay. And then feature level, and then, yeah, actually it takes surprisingly few parameters, like the act of actually getting the device, right? Enable debug runtime. Right, okay, this is basically the same thing that I do on D3D11, like you set break on severity depending on what you want. Enable errors as warnings. This is all really good stuff to be able to adjust. Typically you don't want your warnings to break, but you might want that if you want to be really pedantic about stuff. Corruptions and errors, obviously we want that to just break into the debugger if you're running through Visual Studio. And this is something that, like, I think NVRHI probably kind of requires you to do, or not necessarily requires, but like it might be annoying if certain features just spams the output. So maybe we'll just take all of this and basically do the same. And here's where we create all those queues that we'll want to have. So that's good. And then we are actually off to the races, because here we're already creating the NVRHI device. Right, so that's really good. I think we can almost copy paste that stuff over, but let's see a little bit. Take a quick look here and see what I had previously. So device creation parameters, this thing contains... does it contain anything of interest right now? It actually does, but we're just using this local variable here. So debug device, and then the NVRHI validation is right here. Yeah, okay. Okay. We're basically gonna comment that stuff out. That's the device. And this is all the debug stuff for D3D11. Yeah, there's some important things that we need to do here. Yeah, that's just printing stuff. We don't need any of that. But we do need to set these caps, and this is the important one. Yeah, that's not really relevant for D3D12. Yep, that's fine. So HBAO plus support, you know, until we have HBAO plus in D3D12. Mark that to false. And yeah, that basically all of those are fine. We can just use them, leave them as they are. Alrighty then. Yeah, that would be a D3D12 actually that we need to use here, but the device disk doesn't look the same. Like none of that is actually the same. So we're gonna leave that, and then that just goes away because that's D3D11 specific things as well. Okay, so let's start with the debug things. So here we have parameters dot debug device, and again I'm just gonna do this. I'm gonna do it like this, and then I'm gonna set that to null, and then I'm gonna release that thing. Yeah, and we can actually print this thing. Like that. I think I'm gonna bring this in, but maybe I'll leave it uncommented, or commented out rather, for now. Do the same thing here. I haven't used this actually that thing should probably go there. Here's where we actually start to like see the benefit of using those smart pointers, but I'm not using them right now. Right, so yeah, I haven't used this GPU based validation thing. You know what, let's just enable it with this and see what happens. Right, what's the worst that can happen? Debug controller, yeah. All right, and then the adapter index. So we're getting the adapter already here. We don't need to do any of this adapter business that they are doing. We can quite simply do, let's see, this returns a boolean if it fails, and in D3D11 where's the create device stuff? Yeah, okay, so it's just here. Okay, exactly. So after that, we quite simply create this thing. Device params feature level. Okay. D3D feature level. Yeah, I think that this is probably going to be quite simply 12.0. for now. Or is it? What are they actually using here? Let's run this again, see what feature level they are requesting with these settings of theirs. I'm running on Windows 10 now, so I'm kind of thinking that my 11.1, okay. I do actually want to have 12.0 though, so I think I'm gonna want to have that. 11.1 might be enough, if we're being honest, but still, I think I'm gonna want to have 12 as sort of like a baseline if you are running with a 12 backend. Otherwise, you might as well just use the D3D11 backend, which is still probably going to be around for a while at least. Right, and then if that fails, we could simply return false here, and then the game goes like I could not create direct 3D device or whatever. If NVRHI uses Agility SDK, you can probably use 12. Let's actually Google this thing. Target features supported by DirectX 12, including shader model 5. I mean, isn't this pretty old at this point? Yeah, like if you're going for 12.2, which is shader model 6.5, this would probably require DXIL shaders, right? Which I'm gonna get to eventually, but not today. So I wouldn't want to target that, at least not yet, but like 12.0 seems to me like pretty safe. I don't know if it uses the Agility SDK though. Maybe we can figure that out. Maybe it's actually like a toggle where you can run it in different, you know, different versions. NVRHI obviously doesn't even depend on Direct 3D in any sense. You can just run it with Vulkan, but like I don't know what the backend does. Let's leave it like this for now, and then we can come back to it later. I mean, 11.1 is probably good enough for the game that I'm building, if we're being honest, but I think I'm gonna just leave it at that for now. Okay, where was I? Right, so then we have the debug stuff, and this is the stuff that I actually sort of did previously with Direct3D 11. So device manager, you can see sort of like the same thing, set break on severity right here. So this is now where we're going to do the same thing, but for D3D12. So again, we're going to do the debug device. Just put that there. And yeah, I'm probably going to do this again. And that would be the actual D3D device. Now we're querying this for enable warnings as errors. I am going to comment that out because I don't want that. But I want all of that. Yep, I think that is what we'll want to have for now at least. And then we have the queues. Queues, that's good. So what do we have? D3D12 command queue description. So we're setting the flag to be none, and we're setting the type to be direct. That would give us the graphics queue. Then compute and copy. Yes. HR return, what is that? Ah. Right, it's essentially like this. And maybe we can do it that way. Yeah, okay. Let's chill it with the macros a little bit here, right? Do it like that instead. Enable copy, enable compute queue, enable copy queue. I'm guessing these might be kind of nice to be able to disable in some cases. Someone more experienced than me in the chat might be able to tell me if there's like actually like a use case for that, right? But for the time being, I'm just gonna always create them. And then we can see about making it so that you can, well, you can toggle that off later if you want to. Node mask 1. Yeah, okay, yeah, the node is probably just like the physical device or something, right? Okay, and at this point, we have basically everything on the D3D front. Now we just want to create the NVRHI device, right? So yes, we're gonna want to do this thing exactly, but we want to do it with the D3D12 flavor instead. The device is still gonna be the device, but I'm gonna take all of this from donut, plonk it in there, and we'll take a look at this thing. So I think these are just like named differently. We do not have aftermath. Let's just set that to false all the time currently. Log buffer lifetime. What? Ah, right. These are the things that we looked at previously. Yeah, okay. Let's set that to false. Oh, Jesus, I'm losing my voice. Yeah, these are the things that we looked at before, and we're gonna set them to false currently now because I don't know exactly what they do. Enable heap directly indexed. It says allows resource descriptor heap on DX12. I have vague recollections of what a descriptor heap is right now, but let's not push it. I do have a message callback though, which we can hook up here, and we can get nice message boxes with a lot of information if something goes wrong. Where's the thing? It's up here somewhere. There we go. So message callback is that. Default message callback. Why can't you navigate to that? It's like a few lines above you, but okay. Okay, Visual Studio. Yep. Right, so device. Yeah, we can do exactly the same here, all of that. So we're creating the device. If we have parameters enabled, we're wrapping that device inside of a validation layer. So this gives us another device. This gives us a what was it called? Oh, I don't have the ability to jump into NVRHI, but it creates like a validation device. And then that device is the one that we'll actually be using. Otherwise, we just skip that and we get the raw device directly. And then I just detach it because again, I want to handle the reference count here directly and explicitly and manually. Right. That would be the device creation. Or at least the first raw version of the device creation. For bases. And I think I might want to have a look at the tear down here at this point. Right. Okay, I have some macros for this, just to make it a bit easier. I just have to do this if release thing all the time. So C release. C release because release has a capital R. It's a bit annoying. I tend to use non-capital release functions or methods myself. So I have another which is just like basis release and null. And this is now basis C release and null, which is a bit stupid, but it is what it is. So let's just make sure that we are properly disposing of all of these guys that we have been creating here. That and that. Render windows a bit different, so that's fine. So factory, adapter, device. We have the queues and swap chain there, yes. Okay. So queues. Actually, the queues somehow, I don't know if we want to do that in like a reverse order. It probably doesn't make any difference because like they are reference counted. But maybe it's nicer regardless. Swap chain, we have the queues, the device, adapter and factory. Right, that is the okay. Disconnected and reconnected. Not sure what that was about, but let's hope everything is back where it should be. Why did they, by the way, why do they store that swap chain description in a member? Is that important for some reason? They store it in a member so that they can look it up, like the buffer counts and formats and that sort of stuff later. Yeah, maybe that's handy. I guess that can be handy. I wonder, do I actually do the same here in 11? Yeah, I do. Okay, I keep it here as well. Yeah, then you can just like a resize swap chain, you can just use it directly. Okay, that's fine. That is fine. Let's keep it like that. Coolio. So we had a look here, and we were at this now. This is now done. So the next thing that we need to do then is creating the actual swap chain. Let's have a look at how they do that. I'm hoping it's not very different from what we already have, but probably a little bit. So they're using GL framework here. That's why we have these GL framework methods. I'm not doing that currently. I've done it with like the web GPU and the Vulkan and those metal also use that. But the D3D backends in bases have always just used Win32 windows, so I'm doing that currently. But yeah, we basically don't need that. We need the window handle, and we can already get that, and then they're just moving. Oh, they're getting the width and the height from that. Okay. Yeah. Okay. And then again, they have this special processing for sRGB swap chain. We don't really need to concern ourselves with that. We have basically the correct format here already that we expect. So let's go have a look. Why is this complaining, first of all? Swap chain description 1. Okay, so this is interesting because the normal swap chain description has those things in like a buffer disk, yeah, but the 1 doesn't. Microsoft's confusing versioning of these DXGI things, but it's fine. Okay, right, so buffer count is fine. That needs to be just width, I think. That needs to be just height. Let's see, we have slightly different members here. Buffer usage. Okay. Yeah, I think we're probably going to want to actually comment this stuff out for the time being, and quite simply let's see, okay, yeah, this is actually quite a bit more complicated here. It's probably fine, but let's swap chain for H window. Right, so basically until like that point we're doing just the swap chain business. Comment that out so just we can look at what we had. And instead we'll want to use their version of this. Let's bring all of that in. We can get the width and the height from the render window. Like that. Sample desk is always going to be 1. Currently I don't use any MSAA min basis. Buffer count is always going to be 3. We do allow mode switching. Thank you very much. Swap effect flip discard, yeah, that's the one that we've been using. Does this thing actually have like a windowed thing, or is it? Oh, it's down there. Okay, one thing at a time. Cool. Windows handle is there. Buffer usage. They actually have a slightly different usage here, which I'm thinking we might need to have. So they have it hard coded to this basically. Let's see, where is my thing? So that is what they have hard coded it to in Donut. Yeah, we don't do any sRGB back buffers, so that's fine. DXGI Factory 5. So that's like even that's yet another DXGI Factory, is it? I'm not sure. Maybe it's not. It is actually. We have a DXGI Factory 2 here. So what they're doing is they're getting the DXGI Factory and querying for a DXGI Factory 5. Okay. Okay. So they have like a tearing supported member. Well, we can add it here, sure. And yeah, nowadays you can just initialize variables like this in the header, but I'm not going to do that because I don't do it anywhere. So tearing supported false, and we can do it like this. Allow tearing, okay, and then we have the full screen description. All right. Refresh numerator and refresh denominator. I have figured those out already previously, so let's just copy them down here. Scanline order progressive. I'm counting on that being a pretty good idea. Windowed. We can ask the window if it is in full screen mode or not. Like so. And once again, we want like a different different version of this swap chain interface for some reason. So let's have it. Graphics queue. Window handle. All right. Okay. Create swap chain for window handle, and the window handle is also something we get out of the render windows. It's that guy. What is that? It's an hwind with large. So hwind. Something like that. Then we can just plonk that in there. Swap chain desk. Full screen desk. Swap chain 1. This is kind of confusing, this sort of jumping between, you know, all of these H result is what I want here. All these different versions of stuff, right? Is it just me who thinks this is confusing? Right, so then you get a swap chain 1 and and out of that you query for the swap chain version that you know actually want, which is swap chain 3. And that's at least that's how Donut does it. So, you know, I think it's a little confusing, but I'm sure there's a good reason for jumping through these versions. If not a good reason, at least a reason. Rightio. I have printed that there, so let's maybe do the same. Actually, it's probably like there. It's kind of like the closest place to that. Okay, it would be kind of interesting to run this now, but we can't do that quite yet because we still need to implement some of these like resizings and whatnot. And of course we can't render anything until we have our frame synchronization, you know, fences and events set up. But I think once we have this back buffer business handle, I'm gonna want to actually run through this startup code. We should be able to do that at least. And speaking of, the next thing they do here is actually creating those fences. Well, they do create the render targets first, which is basically what we are doing here as well. Create back buffer. Yes. Okay. Yeah, this is probably okay. We're gonna just basically do what they do. I'm not quite knowledgeable enough about this thing to be able to say anything. I think what they are doing here is pretty good. Let's do the same. So what they are doing is basically this. Swap chain buffers, we do have one of those. It's here. We can resize that, and now we can use that swap chain desk, so that I guess that was kind of nice. We call this back buffers. I maintain that is a better name for it. So again with that macro, I don't like that. Where's my if failed? Yeah, exactly. Like so, and swap chain buffers 0. So what we're doing here is resizing to 3 essentially. I want my pre-increment there, thank you very much. So then we're getting out of the swap chain all of those in turn. We're creating the actual wrapper objects for that. Here we can just get the metrics out of that. I think we can basically do, yeah, we can basically do the same that we've done there above, but let's just do it like this. So the format is going to be that. Debug name swap chain buffer. Is a render target. It is not the UAV, that's probably correct. Initial state is present and keep initial state true. Yeah, that's fine. And then we want to have this set to back buffers n, and that would be, I think this is like device, isn't it? Device. I think like so. And do I actually detach it there? I think I probably do. If we look at the D3D, no. Oh, I do it like, I do it, but yeah, okay. Just to, okay. Let's do it the same way here. So we assign it to a temporary, which is a texture handle, which is essentially a ref counter pointer. Okay. And then we figure out, okay, did that actually work? Right. So we're going to release the. Well, we're releasing the buffer here, but we don't actually need to do that, right? We don't need to do any of that. We can just do like, if we don't have a back buffer here, then return false. But then we do back buffers n equals back buffer detach. No, come on, detach. There we go. Like so. Right? So if this fails, well, this is actually not going to release anything because it's going to be null in that case. But yeah, we're being more explicit about it here. Cool. Cool. Okay, good. And I want a depth buffer here. They don't actually do it in Donut. I don't remember if they did it in DX11 or not. Yeah, they don't do it here at all. But I want my back buffers, or rather, I want my frame buffers that point to my back buffers to have a stencil buffer. I need that for my UI rendering. So that is why I put in a depth stencil thingy at this point. And it goes there, and that's good. Okay. So releasing the back buffers then, we have resized the static vectors there to 3, so we should just be able to go. What is it? It's that. Resource in swap chain buffers, release, and then for NVRHI texture text in back buffers text release as well. Maybe we'll just clear those. I'm not sure it matters if we're clearing them, but it might lead to some subtle bugs if we don't do that, and then I might reuse them later on. In most cases, when we're releasing something, we're actually going to be recreating them later because of like a window resize event or something like that, and we're actually resizing them back to 3 here. So, but I think that's probably for the best. Just make sure that we have window width and height, we have the sample counts, we have the formats. Yeah, that looks pretty good. Looks pretty good. Back buffers that time around. Your depth format is D32S8. Is that a real thing or just D24S8? It is a real thing. It is very much a real thing, yes. If you go and have a look in NVRHI, we can see what it actually maps to. Here. So what is this? DXGI format mapping. So we have abstract format, that is the NVRHI format. So that is the D32S8 that you saw. You have resource format, SRV format, and RTV format. So it maps to, well, okay. It is not a real thing in the sense that if you're thinking in terms of DXGI formats. It is not, however, D24, because that would be one of these guys here. But you can see that like the first component switches from a 24 to a 32, and the rest might be slightly different as well because of that. So yeah, it does work. If you're wondering why I use that, it is because when I made my first metal backend, this was back in 2018, I think, or something like that. I was making it on an Intel MacBook Pro, I think MacBook Pro. It had a Radeon at that point. This was before the Apple Silicon stuff. And the AMD Radeon on Metal didn't support D24S8 for some ungodly reason. It required D32S8. And so I was just like, okay, well, whatever, let's use that. And that is why I've been using that. You're quite right in the sense that it's a little bit exotic maybe. It doesn't fit into 32 bytes. I might just be able to switch it back to 24. But so far it hasn't been a problem, so I haven't really thought about it. Okay. What are we gonna do next then? So we have these back buffer things here. I mean, these are probably just gonna read from those vectors, right? Let's have a look here what they are doing. Okay, so the getting the index is actually asking swap chain, whoop, like so. Buffer count is gonna be just reading from that from this guy. Where is the guy? There's the guy. That would be buffer count. get current back buffer is going to be actually doing back buffers, and then again getting the current back buffer index. Yeah, I'm thinking that like this, things like this is why we need to have these very specific versions. Yeah, like this get current back buffer index is only available in this chain 3 or something like that. So that is, we wouldn't even have this function if we were using D3D11, right? Or something like that. Now, right, righty-o. Yep, we don't want to assert anything like that anymore. Instead, we want to do just back buffers index. Maybe we'll instead want to assert that index is smaller than this guy's size. But that is what we actually want to assert, right? Okay. I think we're getting pretty close here. So, yeah, that would be just format. Look at that. And now it all of a sudden now it builds. At least it should build. So we are in debug. We should be able to just run through this startup procedure right now. So let's do it. Start there, and then we're gonna jump to create device, and then we're gonna jump to I mean, assuming we'll get through all of that. I'm gonna jump to create swap chain. Let's see what happens. All right, that was good. That's set to false. Yes, it's good. Okay, so then we're jumping to create device. Enabling debug layers, nice. We're enabling some GPU-based validation. We're creating a device. That succeeded, great. Setting the break on severity, nice. Then we're creating the queues, also nice. Then we're creating the device. Everything just works, great. Let me get rid of that breakpoint there, by the way. Right, then we're figuring out these things. Let's jump past them. Swap chain. Tiering supported, true, alright. Alright. I'm on a pretty bad GPU, by the way, on this machine. This is a 2060. So it's not like ancient, but it's not a very good GPU. Oh, error creating swap chain. Alright. What do we have? Device debug layer startup operation. GPU based validation is enabled. There is results in new validation not possible. That's not necessarily. That's not necessarily the issue, though. I wonder if the window is created. It is probably created. We should probably make sure that is actually happening as well. But it should happen because, like, we're just implementing an interface here, right? Right. Yeah. Yeah, we're creating the window here, and we're getting a valid looking window handle here. Handle is right there. I'm assuming that is looking good. Okay, so what is actually happening? What is that? What's the thing failing? Let's go there again. So we have a graphics queue, we have a handle, we have a swap chain description. Format unknown. That's probably not good. That's probably not good. That's not the format I'm looking for. Right, I'm setting the format here. Okay. Where are they setting their format then? Oh, okay, right. Yeah, let's not be stupid about it. Okay. Hey, there we go. Now we have a swap chain. It's just an RGBA2 norm there. Yeah. Okay. Cool. Cool. So now we can go in here. Release the back buffers. There should be nothing in those, so that should be good. Let's see if this works. Are we actually going to be able to see something today? That would be cool. Kind of mentally prepared to just crash and burn today, since I just like really haven't prepared this at all. But now we basically just have the fences and events and signals. Can it be true? Can it be true? Can it be true? Okay, that's nice. I got a bit nervous about this though. Let's see what does this say. Oh, that's not the one I wanted actually. That's not enabled. Disabled by default. Okay, yeah, okay. It actually it is. I just missed the start of that message. Time to see the first render frame. It takes several minutes. Wow. Wow, that's some heavy stuff. Let's that's actually what I'm gonna do here. And then I'll just do this. Just as a warning to myself that, hey, if you're not prepared to wait several minutes, then let's maybe not enable it right now. Seems like a pretty heavy thing to do if you don't if you're not actively looking for some sort of problem. All right. So release back buffer. This thing is also run here in the destroy, so that should be good. We have the teardown of those back buffers done already. So essentially the only thing that we now need, I'm gonna move these, clump those together because these are kind of related. And let's see, I am zeroing the fence here. I don't want to do that. I want to null pointer it instead. Frame fence events. Okay, yeah. So after we've created the render targets, in right around here actually, is where we will want to create those events, and that one fence. This will be D3D device and frame fence, and then something like that. Swap chain desk, frame fence events. I want that to be a uint32, and I want that to be a pre-increment. Right, something like that. Is there actually like a teardown of this thing? Yes, there is. So show you this. I'm reading through this. Destroy device and swap chain. Where's this guy called from somewhere else? But yeah, so they're just clearing those because they have those magical handles there that I don't like. So we're waiting for the objects, and then we're closing the handles. So we need to do that before they are destroying the swap chain. They're setting the full screen state to false. Yeah, I think I've seen that somewhere else actually. So that's probably good to do. Let's see though. So this needs to happen basically. I think we'll take this here. It's gonna seem so lazy. Like just freaking make a handle there. Just show us what you're working with. And then we clear that. And then if we have the swap chain, then we do that thing before we release it. All right. Yeah. Yeah. I think that should be it. I mean, I'm sure I missed something, and I'm gonna get some crash on shutdown. You always get crashes on shutdown when you're first starting out with D3D12 or Vulkan. You always have something that's still in use, and then you're sort of pulling the rug under the graphics driver, and it just barfs and dies. That happens every time. But okay, that's nice. Now then, let's see what's going on. Frame number. What did they call it? They called it frame count. So they have a present method, just like we do here in this one as well. It's a bit more complex. Right, so I have my own stuff here for like toggling the VSync on and off. MMM. Right, okay. So they're doing something like this, essentially. Again, like, what is with the auto here? Just type. Come on. Show us what you're working with. Okay, VSync enabled, and full screen windowed, and tearing supported. Okay, so, right. We can actually make this like VSync enabled. this. So if we don't have vsync and full screen desk is windowed and tearing is supported, then we allow tearing. This would need to be actually synced somehow. So let's maybe let us maybe I see how it works. It's probably the fact that, like, if we are if you're switching from full screen to windowed or vice versa, then it counts as a mode switch, and then it would recreate that thing and fill in this thing properly. But I think I still want to ask it off the window there. Which mode are you in? Vsync enabled, so that would be like that. Right, and then we have frame fence, frame count. This would be called frame number. Frame fence events, graphics queue, frame fence, frame number, and then pre-encrypt frame number. Right. Something like that. Right, release back buffer. Has some stuff in it here that we probably actually want to do as well. So this would be mdevice, 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 and that again is a handle. Let's see what we have. Set the events, wait for signal object in one frame, not hang later. One frame is probably something that something has been called previously, but it is not called now. It's called begin frame. Yeah, begin frame is what. Begin frame. Whoop. Right? Isn't it begin frame? It is begin frame. And so far I haven't had to do anything here, but now I do. And it is that. Remind myself what these parameters here mean. Create event attributes, manual reset, initial state, and name. Manual reset, initial state. Yes. Okay. Okay, good. Just comparing my use here to those other places in Donut. Make sure that we have the same. Right, so I can dock it there, unfortunately. But what they're doing with this, they're creating it here right after the swap chain creation. They're waiting for them and closing them in destroy device and swap chain. They're setting them in release render targets. They're waiting for them in begin frame and setting them in percent, or set on completion, I should say. Yeah. Yep, same thing there. Same thing there. Set on completion. And actually, like they're not clearing this vector here, which is a bit strange. I think they should be clearing it. They're clearing it here. Oh, no. Right, they're setting it. Yeah, okay. Yeah, they clearly shouldn't be clearing it. Good. Okay. Okay. What about that fence then? Go frame fence. It is created there. It's reset there. We set event on completion and then we signal it. And that's it. So basically I just need to destroy it, right? Frame fence. Am I doing that? Probably not. No, I am not releasing it. I guess we can do it here, right next to these other guys. Frame fence. Something like that. What do you guys think? Is this gonna work? Is this gonna run? Let's have a quick scan through this donut implementation here and see if we've missed something crucial. Move window onto adapter. We don't have that, but I have my render window handles that for us. Report live object. That's nice. We'll probably want to have that actually. Shutdown. Okay. Yeah, well, I'm gonna want to have that. That's really nice. Let's create a function here for it. Report live objects. Right. Just take that and simplify it. Okay. Should actually I need to do it like this. That should probably be like a hard error. If we're trying to report something but we can't. And what do we have? Ignore internal, that's good. Summary and RLL detail. That's basically exactly the same flags that I had for D3D11. So that's good. And where was that called? It's called in shutdown if we have a debug device going on. So destroy, I think it is called, yes. Where do we actually do that? Is it like maybe here? If is it device creation parameters, I think? Debug device, port live objects. That should be good. Okay, let's build that. Keep going. We immediately found something to add here, so that was all right. Yep, we don't need that. We don't need that. Create device. We have basically all of that. Create swap chain. We have basically all of that. Destroy device and swap chain. Create render targets. Release render targets. Resize swap chain. It basically looks the same as D3D11. I'm sure there's gonna be some funkiness, some of that stuff, but let's see. Begin frame. I'm sort of already doing this, but I'm just doing it slightly differently. I don't think there's any difference between this and the D3D11 one, so let's not think about that right now. Then we have this stuff. We've done all of that. We've done the presenting. Yeah, I think we're pretty well covered here. So let's run the thing. Hey, hey, we have things. Let's bring down the volume again. So we got some warnings here. Viewport 0 is non-empty, while the corresponding scissor rectangle is empty. Nothing will be written to the render target when this viewport is selected. Huh. Okay, that's fine. It's probably something that I should make sure are in sync. Yeah, the stupid thing with like this video is that it kind of like runs out of what should I say? Runs out of runway. Like the decoding thread is sort of like slow enough that it just can't catch up, and then nothing ever gets updated in debug mode. Let's try to actually load a game. Okay, it's initialized. SSAO effect. Okay, this is probably something to do with that HBAO not being there. So let's go to render options and just disable HBAO for now. It's alive, yeah, it seems to be, more or less. Who would have thought? Who would have thought? Plane and car is perhaps like the simplest thing. Right, so okay. Look at this. Look at this thing. D3D12. Who would have thought? See if we can run the actual game. Binary blockout. Attempted use of a volatile constant buffer render scene data CB before it was written into. Ah. Ah. That's not good. That's not good. Oh, we have some nans in the sky, I think. It's very smooth though. It's very smooth. The loading was a bit slow. Might have to do something about that, I think. And of course, I'm still running on DXPC shaders. I want to switch to DXIL shaders. But hey, look at this. We have a thing. Some issues, sure. And I think that's a NAN. Probably. That looks like a NAN in the sky. So not a number situation going on. And some slightly slow loading and some volatile constant buffer errors. That's actually interesting. Why wouldn't the like volatile constant buffers are like an NVRHI thing? they're not actually a thing in any, you know, actual graphics API or anything like that. So I'm not sure why the NVRHI validation didn't catch those, but or it did. It did now with D3D12, but I think it should have caught it already with D3D11. But damn, you're already running. Yeah, I just got this working. There's some stuff here to fix. I think that's like a NAN situation in the sky with like there's the sun there in the middle of that thing. That looks very much like a not a number kind of deal. And some those are like clouds. It's supposed to be clouds. That sort of thing. But yeah, it runs. Yeah, not sure what I was expecting really. Probably not this. I was thinking it would be a pain to get into the main menu. We don't have the HBAO here, which is like this. I think this just looks wrong. With VSync on though, this looks really, it feels really smooth. I think there's something with the D3D12 presentation mode. It's just like, oh, it's so nice. So very nice. So very smooth. I don't think D3D11 feels quite this smooth. And because the sky is so black, my auto exposure just goes crazy and like makes everything very bright, as you can see. So yeah, I need to figure out what that is. That's about. But okay. Not bad, if I may say so myself. Where's the thing? There's the thing. I don't get cars driving on my screen after running a D3D device on swap chain. What? Really? I thought that's what everyone gets. Isn't that the norm? I don't want to look up because the sky is so broken. I just want to look down, see, seeing things that work. yeah, I think this is the beauty of NVRHI, right? The beauty of NVRHI is that you quite literally create a device and a swap chain, and then you get stuff on the screen. You know, if you've already written something using NVRHI. If we're being honest, I wasn't expecting it to work this well today. And of course, it's not fully functioning. But hey, what is this now? 3 hours, including, well, excluding the break I had. It's basically 3 hours worth of work, and it looks like this. So, super happy with how this turned out. Gonna be interesting to see what I can do with BXIL shaders, because like the shader code generation from FXC is not good in some cases, especially with like the grass. It's gonna be quite bad and slow. So yeah, yes. Honestly, the smoothness in this presentation mode is just so nice. I'd be tempted to try full screen here now, but it might just break, and then I might have difficulties getting out of it. So I'm gonna do that offline at least first time, and then see how that works. And I guess it might be funky and wonky with OBS anyway. So let's not do that right now. But this is cool. Let's try a few different things here. So let's unlimit that. It doesn't feel quite as smooth with just an unlocked frame rate. We're running the NVRHI validation layer now, by the way. So it's gonna slow it down a little bit. I'm gonna set the frame rate cap to 60. D3D is going towards Spur V, by the way. Yes, I know they are. The funny thing is that I'm already excuse me. I'm already compiling all my shaders to Spur V. Not because I have been doing a lot of Vulkan lately, but because Spur V is used to cross-compile to WGSL for the web GPU backend that I was using up until very recently, and also to Metal. And now that I've ported to NVRHI, none of those are going to work. I might write a backend for Metal for NVRHI at some point, if I can be bothered. But yeah. Anyway, I'm actually already compiling to Spur V for those two, just as a sort of intermediary format. But if I understand it correctly, like DirectX expects Spur V that is compiled with like DXC, and I'm using GLSlang validator for that, so it might be a different kind of Spur V. But yeah, I need to look into all of that. I think anything is going to be better than the FXC stuff, right? That is just horrible. It's horrible. Like I had on this very computer that I have now going with an AMD card, I had some really bad slowdowns from this grass in certain situations, and the web GPU backend did not suffer from those. So I'm thinking like the only real sort of sensible explanation there is that the shader code generated is just that much better. So, all right, let's. I'm gonna probably call it a night soon. Have some stuff to think about here about how to bring this forward, or if I want to do it right now. But I want to try to run that without the validations. Just see if it gets faster and how much. In that case, it does get faster. Like this loading is a bit slower maybe. Right, so that's not actually, that doesn't come from the validation. That's just like that's an actual error. It might be that the black sky comes from this, by the way. Might just be that this is the result of that. Yeah, okay, I need to profile this like properly. Profile this properly later on. But yeah. Okay, that was something. We can try this other game that I have, which is running on the same engine, which should now also be possible to run in this with this new backend that we have. If we just actually select it, actually, let's make sure it runs first with D3D11. Yes, yeah, this is D3D11, and okay, everything is pretty slow now for some reason. I'm not sure why. Maybe it's just like the. I'm looking at the packaged versions. Right, so this is how it should look. The border might be completely broken if the sky is broken with D3D12, but let's see what happens. So, again, copy this thing here. Where was it? There we go. GFX API D3D12. And put it there. And it is possible that it just breaks completely. Okay, we got into the menu at least. That's good. And we're probably gonna run into that same error, I assume. Yes. Okay. Yeah. Okay. Well, it looks pretty much the same. Yeah, I bet the sky is actually because of that error. So smooth. I wonder what is actually giving this smoothness. Is it just like the presentation mode or whatever? What is it? It just feels so very smooth. It's awesome. Oh, hey. Uh-huh. What? All transient resources bound. Okay. Yeah, I mean we're getting validation errors and everything, so probably not worth looking all that deeply into right now until we have all of these things cleared. Let's see, can I jump forward a little bit? Meeting Diego. It's right here. Let's see, does it crash in the same place again? Nah. Doesn't seem to do that. Yeah. All right. That's nice. Everything's basically working. I don't even get any corruptions other than that sky thing. That's cool. I'm impressed. Not by myself, but by NVRHI. Yeah, NVRHI is awesome. Oh, yeah, we're gonna crash here. So that's something I'm gonna have to figure out. It is in my code though. It's not even inside. It's not inside NVRHI. Let's see if we can view this intro here. Attempted use of a volatile concept buffer. Scene data, CB. Yeah, that is the name of it. It's just like maybe it could have quoted it or something. Okay. All right. Hey, cool. All right. I think this is it, folks, for today. Thanks for hanging around. This was kind of fun and interesting, and we got pretty far. Sometimes my genius is almost frightening. Yeah, it's been a good couple of days, let's just say. You know, he said while the sky was just complete bonkers. But still, I maintain that it's been a good couple of days after feeling like a slog for so very long. Yeah, do check out NVRHI if you're curious about D3D12, but don't really feel like going quite as deep as it requires of you. I'm sure I can figure out these snafus quite easily. And of course, the D3D11 version still works with the same code, same renderer, same shaders even. Although I'm hoping to get better shaders for this version pretty soon. And man, this smoothness to this is just something else. I'm sure it doesn't come through on the YouTube video, but I am fully intending to release a pre-alpha 2, which is going to be like concentrating on these tech things. So it will have the NVRHI renderer, and you will get to experience this for yourselves. Just the smoothness of this thing is awesome. So nice. What happens if we create something that we haven't created before, so that we wonder if is there such a thing here in this I was thinking I would force it to like load a texture or something, but I think all of these things are probably already existing here in the world. Whoa, hey, physics wonking out a little bit. Gripper truck. Yeah, I should finish this vehicle too. It's still very early phases. Yeah. All right. Anyway, let's call it a day. It's getting pretty late here. If you do find this interesting, be sure to subscribe. I'll be sure to stream some more relatively soon, at least compared to what I have been doing lately. And if you'd like to play the game, join the Discord. There's a link in the chat. There's links, basically all of my descriptions for all my recent videos. There's going to be a fully public version relatively soon, but for now you have to join the Discord to get the link. And yeah, see you next time, I guess. Have a good evening, and thanks for today.